Hey guys, welcome to another video. So today we're going to continue on with the good question series in the extension 2 syllabus. Today's question comes from the topic of proofs and relates to a contradiction type question. So before we dive in, as always, if you haven't already done so, please like the channel and subscribe to the channel, like the video and tell your friends. Guys, let's get started. So today's question comes from Balcombe Hills, 2023 trial paper for 4 marks, which I think I was a bit surprised because I think the difficulty of this question isn't that high and the duration of time required isn't that high. 4 marks, it's a lot of marks in a 4-unit paper, right? So, but here we go. Proof by contradiction that there are no positive integers, P and Q, such that that expression is true. Now, obviously by contradiction, you assume the negation where we will have positive integers where that guy is true, right? That's the negation. And then we basically prove that that negation is false, right? And it isn't true. So therefore there's a contradiction. Therefore your original statement is true. So for this question, it's all about looking at the expression, right? 4p squared minus q squared. Now, if you're a 4-unit student, you should be able to recognize that that is a difference of 2 squares. And that's how we'll be unlocking this question. So let's set it up. So set this question up as always, because it's contradiction. So assume, right, that 4p squared minus q squared does exist, right? Is true where, and this is where the negation is, right? Where p and q are positive integers. So it's really important here is the notion of positive and integers, right? Because once we get there, we factorize this with difference of 2 squares. So 2p plus q and 2p minus q equals to 25, right? Now, once you're here, you sort of realize that, well, there are 2 brackets here that multiply, give me 25. So 2 factors of 25, right? And because everything's integers, right? Because they're all integers, I'm expecting this bracket and this bracket to be integers, right? Now, and then you go, well, let's explore 25, right? So 25 can be a product of 2 integers made up of either, let's say, 25 times 1, 1 times 25, and 5 times 5, right? There are no other positive integer combinations that will make 25. Now, first thing, right? We can rule out this option, right? This option's gone. Why? Because q is a positive integer. It's greater than 0. And therefore, if q is greater than 0, then 2p plus q, right, can never equal to 2p minus q, right? That doesn't make sense because I'm adding a positive number and minusing a positive number. I can never get the same answer, right? It's always positive. It's always greater than 0. It can't be 0, right? Can't be 0. So what does that leave us? That it's either one of these 2 pairs, right? One of these 2 pairs, that's the correct one. Now, the way we're going to do it then is we're going to go, well, why don't we, because there's a plus and a minus, we're going to let this guy here be the plus case and this guy here be the negative, be the minus case. So 2p plus q is bigger than 2p minus q because q and p are positive integers, right? Now, does that make sense so far? So 2p plus q has to equal to 25 and 2p minus q has to equal to 1. And hopefully when we equate it, we then get a contradiction, right? Let's have a look. So if I equate that guy and 2p minus q equal to 1, so let's solve these guys simultaneously, right? Let's go call this guy number 1, call this guy number 2. 1 plus 2 will do it, right? Because when you add them, you get 4p equals to 26. What's that? P equals to 6.5, right? Which is a contradiction. Why? Because that is not an integer. P has to be an integer, right? Therefore, I've done it. And that's really the proof, right? It's a nice, clean question, right? Therefore, contradiction, yeah? Because P is an integer, right? Therefore, right? And I'll do the real thing, right? Therefore, all right, there are no positive integers. No positive integers such that (4p squared minus q squared equals 25). So guys, not a hard question, but at the same time, quite an interesting, right? Get as many proof questions down your belt because the range of it is still quite wide, right? And the practice, there's not a lot of questions. There's not a lot of, history of this yet in the syllabus. So get as many of these down your belt and it'll be healthy for you. Guys, hopefully that was okay. I'm going to end it there. Hopefully you liked the video, subscribe to the channel and tell your friends. Thank you very much.